Use Descartes' rule of signs to determine the possible number of positive and negative real zeros of the polynomial p of x equals 2x to the fifth plus 5x to the fourth minus 8x cubed minus 14x squared plus 6x plus 9. Then find all the real zeros and factor p of x completely using real numbers. So to start off with Descartes' rule of signs, we look at the number of sign variations in p of x. So here from 2 to 5, that's positive. Positive to positive, there's no change. But then here, positive to negative, we've got a change. Negative to negative, no change. Negative to positive, there's a change. And then positive to positive, no change. So I have two variations, so two changes. And I know that the number of positive real zeros will have the same parity as this. So 2 is an even number, and so I know that I have an even number of positive real zeros, and I can't be more than 2. So that's the only even numbers I can have are 0 or 2 positive real zeros. Okay. That's not the actual zeros, it's just how many there are. Then I look at p of negative x. P of negative x. And for p of negative x, a quick way to get it is just to know any x that has an odd exponent, we're going to change the sign in front of. And any x with an even exponent, we will not change the sign in front of. So here we have an odd exponent, so we're going to change that. So negative 2x to the fifth. And then here we've got an even, so we don't change that. Plus 5x to the fourth. Here we have an odd exponent, so we change it. Plus 8x cubed. Here we have an even, so we don't change it. Minus 14x squared. Here we have an odd exponent, and so we do change that. Negative 6x, and then plus 9. All right, and then we look at our sign variations. So here we've got a change from negative to positive to negative is a change, to negative, and then to positive is a change. So here I've got 3 changes. 3 changes. So this is an odd number, so I do all the odd numbers between 0 and 3. So that's 1 or 3, and this is how many negative real zeros I have. Now I need to start finding my zeros, and we're going to use the Rational Zeros Theorem to do that. Rational Zeros Theorem. Okay, and this is where we take the factors of the constant term. So the factors of 9 are 1, 3, and 9, and plus or minus those. And then we divide by the factors of the leading coefficient, which is 2. So the factors of 2 are 1 and 2. And we're going to do plus or minus. We do all the divisions possible here. So we get plus or minus. 1 over 1 is 1. 3 over 1 is 3. And 9 over 1 is 9. And then 1 over 2, and 3 over 2, and 9 over 2. Okay, so these are the possible rational zeros of our polynomial. So now we have to start checking these zeros. And we're just going to, as we're going, we're going to keep in mind how many possible positive real zeros and negative real zeros we can have. So we're going to go ahead and do synthetic division. List our coefficients of our polynomial. So 2, 5, negative 8, negative 14, 6, and 9. And then I pick a number out here to check. So I'm going to go ahead and check 1. And I go through and do my synthetic division. And I think that you're probably comfortable with synthetic division at this point. So we're just going to blast through it. Okay, and we got 0, which means that 1 worked, which is awesome. Now, that was a positive real zero. So that has now, I've now cut out this possibility. I know that I don't have 0 real zeros. I know that I have at least 1. That means I have exactly 2. So now I need to keep going until I find another positive real 0. Now 1 worked here, so let's go ahead and try it again. So 1. Okay, it didn't work, so I'm done with 1. And let me go ahead and just get rid of that work that I did because 1 didn't work a second time. And we'll move on and try the next positive number. So I'll just move up to 3 and see if that works. And right here, I'm just going to stop. These numbers are getting ridiculous, right? There's no way that this is going to get me to a 0. So I know 3 does not work. Okay, so now I'm going to go to my next positive number. And since 3 kind of was going crazy and making numbers really big, I'm thinking maybe 9's not going to be the best choice here. I'm going to go ahead and skip it for now and see if maybe one of these fractions works out for me. So let's go and try 1/2 and see what happens there. And obviously we're not going to get 0 here either. So 1/2 did not work. Okay, let's go ahead and move on to our next number. So let's see, we skipped 9. And I think we're going to be good with that. Let's go ahead and do 3/2, see what happens. And there we go, we get 0. So 3/2 worked for us. And we've done now 2 positive numbers. So we got our exactly 2 positive real zeros. And now we can move on to our negatives. So let's go ahead and start testing some negative numbers. We will go with, let's start with -1. And that's pretty awesome that worked out for us as well. And you know what I like to do? When I've got 3 numbers right here, these 3 numbers indicate that I have a quadratic left. I don't know about you, but I hate working through all these numbers and testing them all. It's just tedious. And so what I'm going to now do is write what I have so far. I have x minus 1 is a factor because of this here, and x minus 3/2, x minus 3/2, and x plus 1, and then this here is 2x squared plus 8x plus 6. And we want to see if we can factor this even more. Now I'm going to, first of all, I noticed that there's a common factor of 2 right here. I'm going to go and pull out the 2 from this thing, and I'm actually going to put it with this over here to get rid of that fraction. That's just something to make it look a little bit nicer. So if I put a 2 in here, I get 2x minus 3. Then I've got my x plus 1, and I factored a 2 out of this, so I'm left with an x squared plus 4x plus 3. And now this quadratic is super easy to factor. We have, that's an x plus 1 and an x plus 3. And these 2 terms here, those are the same 2 factors. So we can write this in a slightly condensed form. 2x minus 3, and then that's an x plus 1 squared and x plus 3. And so there's our factored form, completely factored form of p of x, and we can state our zeros that we've found. From this first one here, we have x equals 1, and that was a multiplicity of 1. And here we have x equals 3/2. That also is a multiplicity of 1. These are because of the exponents on those. The next 0 we get is x equals -1, and that 0 has a multiplicity of 2 because of the exponent. And finally, x equals -3, and that has a multiplicity of 1 as well. And you'll notice here that counting multiplicities, okay, we have 2 negatives here and a negative here. That's 3 negative zeros, okay, which matches what we wanted. Up here, we wanted 1 or 3 negative real zeros. And we found 3 of them, okay? And we had, of course, those 2 positives that we were expecting earlier as well.